Here's another situation that we haven't run into yet when we're talking about antiderivatives. If you were thinking in terms of regular derivatives, you might be thinking quotient rule, but there's no quotient rule for antiderivatives. Instead, the only real thing we can do with this is splitting up the fraction. That is, dividing x into each of these terms. So x squared over x, that would give me just x. 9x over x, that's just 9. And then 4 over x, I'll leave alone. And then dx is applied to all of these things, so I'll write that in parentheses. Now we can do our regular piece-by-piece integration. So if I integrate x, or I take the antiderivative of x, I add 1 to the power, so that's x squared, and divide by the new power. The integral of 9, well, there's no x there, so that means this becomes 9x. And now, well, this is different, right? Because our x, 4 over x, is the same as 4 times x to the negative 1. If I add 1 to the power, I'd have x to the 0, and then divide by the new power, divide by 0. Remember, we can't do that. This is the special case where when you integrate 1 over x, you get the log of the absolute value of x. So this 4, all that means is there is a 4 in front, and I write log absolute value of x. And then since we're doing indefinite integrals, I always add plus c. So the integral of this, x squared plus 9x plus 4 over x, is x squared over 2 plus 9x plus 4 log absolute value of x plus c.